In this lesson, we're going to work out how fast something can travel, i.e. its speed. Now, I don't know if you remember, but in the last lesson we looked at this remote control car and we're trying to work out what we'd need to make it, to work out the speed of it. What equipment would you need? Now, to work out the speed of this remote control car, you would have to know how far it was going, i.e. its distance. You would need to know how long it took, its time, and you need to do something with those numbers to work out its speed. So we'll have a look at an example here to try and tease that idea out. So we'll go back to this idea of Anne travelling from Fort William to Inverness, and if we think of it, it took her 3 hours to travel 60 miles. How far did she travel in 1 hour? Now in 1 hour, well, if she does 60 miles in 3 hours, if you divide that by 3, you're going to get what she does in 1 hour, so that's 20. So her speed was really 20 miles per hour, and that's what a speed's recorded in miles per hour. If you think about travelling in your own car, it goes at certain miles per hour. Now, in terms of using this for a remote control car, the remote control car maybe doesn't go miles per hour. You could, but we might measure it in the classroom in meters, the distance in meters, and we might measure the time in seconds. So that would be a different unit. That would be meters per second, and so on. Okay, so let's look at some more examples of that idea. So to work out the speed of something, basically what we're doing here is we're taking the distance it travelled and dividing it by the time it took. Okay, so the first one here, the distance was 20, the time is 5, so it'd be 20 divided by 5. Now that gives you 4, but it's really important to use the units correctly. So distance is in meters, times in seconds, so the speed's meters per second. And the second one, the distance is 64, the time is 4, so divide them and you'll get 16. But here, because the distance is in miles and the time's in hours, the speed's miles per hour. So important to pick that up. Some people find that difficult, but if you look at the 2 units here, you'll get your final unit for speed. Next one, 80 divided by 16, that's going to give you 5, and it's kilometres per hour, because distance kilometres and times in hours. Here we'll get 15 miles. Now, we did talk about this in the last lesson, but 1 hour and 30 minutes. We want the answer of time in hours completely, so that's not 1.3. 30 minutes is half an hour, so it's 1.5. So we're doing 15 divided by 1.5, that gives you 10 miles per hour. This is a similar idea in the last one here. It's not 65 divided by 3.15. 15 minutes is a quarter of an hour, so it'll be 3.25. And you might need a calculator for this one, but 65 divided by 3.25 is 20 kilometers per hour. Okay, so that allows us to go into today's lesson, which is about calculating speed. We're going to use this formula here. Choose the correct units in your answer, which is important, and lay out your work neatly and tidily. But before we do that, we'll just quickly look at Usain Bolt. He's the fastest man in the world, or was. Nobody's ever beaten his 100-metre time, or his 200 for that matter. And we'll look at this formula we've been using. So the formula we've been using is actually to calculate your average speed. It doesn't calculate the fastest point of the distance you're travelling, it just gets the average over the whole distance. So when we're working out Usain Bolt's speed here, it's his average speed, and I'll talk about that again in the next slide in a second, but the distance he travelled was 100 metres, and the time he took for his world record was 9.58 seconds. So if you take 100, divided by 9.58, again we're going to use a calculator here to do this, and if you type that into your calculator, you can have a go yourself and pause the video, but it comes out to be 10.4 metres per second. So that's his average speed over the whole race, but there's a bit more reading needs to be done into that, because at the start of the race he's a bit slower and he's a bit faster at the end of the race, so that's not his top speed, that's just the average speed. So I've got a good bit of data here that I took off the internet, and what it does is it tells you, if you don't know athletics, you might not know some of these people, but it tells you like some of the fastest men in history that have run the 100 metres, Ben Johnson, Carl Lewis, and so on. There's Usain Bolt at the end there. Now that wasn't his world record time. His world record time was done in 2009, 9.58. This was 2008 at the Olympics. And he got 9.69, which was a world record at the time. But what it does highlight, these are times broken down for every 10 metres. So in the first 10 metres, He did it in 1.85, Asafa Powell 1.89, and so on. But if you look down here, and this is a kind of interesting part here, this is his fastest point in the race, the quickest he does the 10 meters. He does it at 0.82, faster than anybody else. And he continues that from 50 all the way up to nearly 90 meters. Again, at 90 meters, these guys are all doing the 10 meters in 0.87 and 86 and 85. He's doing it in 0.83. So this is where Usain Bolt wins and beats everybody else, this part of the race here. And you can see that when he runs, he gets this big gap between his runners, usually towards the end of the race. Now, to get his fastest time here, then, if we take the 10 meters that he travels and divide it by the fastest time he took, which was 0.82, you'll get his fastest speed in the race, which is 12.2 meters per second, which is absolutely ridiculous if you think about it. Our classroom at school is about 6 meters, maybe just over 6 meters. So he travels double the length of our classroom in 1 second, which is kind of mind-boggling. But anyway, let's get into the exercise. And before we do that, maybe copy down this formula and put it in a wee box or stars around it, whatever you want to do. Right, let's look at the first question here. So use the formula to find the average speed of these journeys. So first one, make sure that you write down the formula. So speed equals distance. You can put d over t or d divided by t, it's up to you. Line equal signs up, 15 divided by 3, and really important to write your answer, but get your correct units. So it's miles an hour, so it's miles per hour. The second one here, speed equals distance over time again. It's 28 divided by 7. I'm not going to give you the answer to this one, but it's in kilometers per hour. Okay, so like before in the last lesson, I'm not going to use the textbook here. I'm just going to use the screen. So what I'd like you to do is, I'll see if this works in full screen. And I'll move that out the way. I'm not sure it does. I think I might just scroll down. So what I would do is try the first two. Maybe pause the video. And then try question 3. And pause the video. So have a go at those, and then I'll go over the answers. Okay, hopefully you paused the video there. We'll now go over the answers to these parts. So, first one, 15 divided by 3, that's going to give you 5 miles per hour. 28 divided by 7, 4 kilometers per hour. 140 divided by 10, that's 14 miles per hour. And 350 divided by 2, that's 175 kilometers per hour. Question 2, it says here, watch the units, so be careful with them. So it's 30 divided by 2, that's 15 kilometers per hour. 400 divided by 8, which is 50. I think 40 divided by 8 is 5. And then 200 divided by 10 is 20 meters per second. 30 divided by 4 is 7.5 kilometers per hour. And then this one here, I would do 42 divided by 7, which is 6, and that gives you 6,000 miles per hour. And then think 21 divided by 3, which will give you 7. So that gives you, I think it's actually 70,000 there. That's a mistake. I don't know if I can change that. I'd like to see if I can. I'll chuck an extra 0 in there. Okay, right. So, last one. Right, 420 divided by 7. I think these are all miles per hour, so that would be 60. So 42 divided by 7 again, think that way. 6,000 divided by 8, 750. 273 divided by 3 is 91. These are all miles per hour. 18 divided by 2 is 9, and 549 divided by 9 is 61.